There we go. Welcome
Hooray!
to episode 116, which we don't have a title slide for, but you'll get it. And we got Holly and Jose, and Jose is here to talk about
Hello.
Helm and Argo CD. Um, Before we get running, just a little news update that this weekend, Guillaume, who from the Quarkus team, had the fun of making the main branch of Quarkus is now Jakarta targeting Jakarta, and yeah, like someone said that it just worked. So it's like no one can see all the amount of work that actually gone into to make this work, but we've had a lot of automation set up, which we might do an insight on in the future on how we actually did this. But basically, main is now Jakarta enabled. There are a few things still not integrated, like the latest Hibernate 6, the latest micro profile, but that's why we are making it main, so it's easier. So if you have full-on latest development, then go on Quarkus Dev. There's what's called a thread on what to be aware of. I don't think there's anything really. It was just wait on the CI system to calm down after all the rebuilds. But that's it. Okay. Otherwise, yeah. Well, let's jump into it. So, Jose, you want to introduce yourself?
Sure. Yeah, well, I'm working in Red Hat from 2020 as a senior software developer. I'm working in the Snowdrop team within Red Hat, trying to improve the developer tools for cloud native and cloud technologies.
Yeah.
And in this session, let's start trying to try to implement a continuous delivery workflow using a new Quarkus Helm, a new extension called Quarkus Helm and Argo CD.
Yeah, it's just a simple topic of.
Yeah. Well, this is me. These are the tools we are going to use during the demo. But first of all, what is continuous delivery workflow and what do we need it for? So to start with, to deploy something into Kubernetes or OpenShift, we need two things. The first thing is the container image to be published in a container registry. In this session, we are going to use my Quio account, but we could have used Docker Hub registry on any other. And the second thing we will need is the Kubernetes resources. For these two things, Quarkus makes things a lot of easier just to including the necessary extensions. For example, in the case of the container image, you can use the container image Docker or GIF or build packs, any other. And to generate the Kubernetes resources, you can use either Kubernetes or OpenShift if you want to deploy the application into OpenShift, of course. So what is the continuous delivery workflow? The continuous delivery, once you have deploy your application into Kubernetes, if you make some changes into the Kubernetes resources, you will need to replace somehow this application to update the latest changes. And this is where continuous delivery tool comes to play. A tool, the tool we are going to use is Argo CD. Argo CD will watch for some resources. In this case, I'm going to use the Git repository where the Kubernetes resources will be hosted. Argo CD will install and synchronize every changes Argo CD will find in this repository to update application into Kubernetes. So the idea is to delegate the deployment to this tool instead of manually installing or synchronizing your application.
Yeah, and just a quick, just for anyone listening who have questions, they can ask questions in the chat, then we will relay them to Jose. And just one thing, so Jose, you didn't say it yourself, so I'll say you also worked on some of the decorate stuff that we've done to make deployment easier for Quarkus. So if you use Quarkus to build Kubernetes resources, so not Helm, but just Kubernetes resources, you've seen that we generate Kubernetes resources that is just what's called, it's not just static, it's based on what the application contains and do, like, oh, add the health check endpoint, etc.
Exactly.
And we've actually had a lot of requests for Helm in the past, but we had an example that said, here's how you do it generically. But then, yeah, I guess it's like a few months ago, you and Ionas talked about doing this, where we do the same thing of being able, instead of having a static Helm resource you have to adjust to your use case, we flip it around and make it so that the Quarkus app can kind of, hey, these are things I need, and then the Helm generation does it for you, right? That's the
exactly. This is actually what I want to say, because so far Argo CD is able to watch static Kubernetes resources. But why do we need Helm here? Well, the main features for Helm, well, Helm is a package manager for Kubernetes, so you can package applications, including the dependencies, databases, or any other services your application might need it. Helm also allows you to configure your deployments when installing the package. And this is something you cannot do. For example, if you want to override the container image to use when installing the application into Kubernetes, you cannot, you cannot do this using the static resources that are generated at build time, because this value is hard coded by that time. And this is where Helm comes to play here as well. And it really helps. So if you don't have more question, I can continue.
I've got one more question.
Sure.
About the Argo CD bit, because I always associate Argo CD with the conversation around GitOps. So is this a GitOps thing, or is this more generic than GitOps?
No, it's a GitOps. Argo CD follows the GitOps pattern to deal with Git repository and to make the deployments. And Argo CD is for me some important point, is part of the Cloud Native Computing Foundation. Okay. And another important point for Argo CD, you can configure the sources of your application to be either a plain directory containing Kubernetes resources or Helm charts. In this demo, we are going to use the Helm charts that the Quarkus Helm extension will generate it, but just by having the dependency in the class path. Okay. So what is Helm? Helm is the package manager for Kubernetes, is also part of the Cloud Native Computing Foundation. And the packages in Helm are charts. And chart is a folder containing several files. The main file is the chart.yaml file, which is the metadata of your chart, is where you can set the name, the version, the developers, your dependencies, this kind of stuff. Then you have a folder, the template folder, with the resources that will be installed as part of the chart installation. And the values.yaml file is where you can place the configuration that is mapped in the template resources. This slide just show how easy it is to use Helm, the command line. But for this demo, you don't need either the Argo CD command line, you don't need the Helm command line, because we are going to delegate this into Argo CD, and we are going to push the changes into a Git repository. So you don't need to install any command line for if you want to try it yourself. So for me, so can I start the demo? More questions?
Yeah.
Okay. So let's start. So for this demo, I'm going to, as I say, I'm going to use a Git repository I create beforehand, the Quarkus Insights Helm. in this repository, I provide some information about how to install Argo CD. I'm going to use OpenShift. So I use the Argo CD operator. It was really easy to install, but I provide some documentation here. And I also install a Helm repository. Just if we have some time, I can demonstrate that the Quarkus Helm extension can also push the charts directly to the Helm repository. So let's start by creating, this is the folder, the same folder we have seen. Let's start by creating a simple application. Let's use the Quarkus command line to create a application using the, let's use the REST easy reactive Jackson. This extension provides you some the REST support using REST easy and also JSON support. The group name and the artifact ID. This will create a new folder called ACME. Let's go to the ACME and let's open IntelliJ with it. Have to see how it looks like. Because we select the easy reactive Jackson and a hello world resource is added automatically, so we can directly interact with Quarkus. Let's see how it looks like. The greeting resource.
Yes, for now it's just a normal default generator.
Exactly. Yeah, the hello resource. We can start our application dev mode and we can see the hello resource is up and running. This is, I mean, we are not doing anything special. We just create an application using REST easy Jackson and that's it. Hello, our application is up and running. Not yet. The first thing, as I mentioned in the previous slide, we need two things: the container image and the artifact. So let's start by our application is up and running. If we call to the hello resource, we will get the hello from REST reactive. So good so far. So let's start by adding the container image Docker extension. You can use any one any other you prefer. Image Docker. We need to configure this extension to build the container image and also push the container image into any container registry. I'm going to use mine, my account in Quio. So the first thing we will need is configure image build true push and configure the name of my final image, which is going to be to use the Quio registry, my username, and let's call it demo 1.0. So when we install, when we build the application, we will see now that the Quarkus container image will now build and push the container image into my Quio account. So we have one dependency resolved. We already have our container image. You will see the push work in this registry. So let's start now by adding because I'm going to use OpenShift, I'm going to use to install the Quarkus OpenShift extension. Okay, when you are using OpenShift, by default, OpenShift is coming with a new container image called source to image. This container image is so useful in OpenShift because from the sources, OpenShift can build the image inside OpenShift and run your application. But we don't want this builder because we want to use this image. So let's say, hey, I don't want to use the source to image. I want to use Docker, the Docker one. What else? If we want to use our application when it's installed in OpenShift, we need to expose the root. Okay. By default, when using OpenShift, you are OpenShift using is creating a deployment config resource. This is so useful because OpenShift can watch new container image versions and automatically roll out your application to keep this deployment with the up-to-date version. But we want to delegate this to Argo CD. So let's use a normal deployment kind, the deployment one, which is the default for OpenShift, for example. So if we build our application now,
so the idea was you made the OpenShift handling in Quarkus use the default Kubernetes one, right? Or
yeah, I don't want to use the source to image, which is the default. Actually, if you don't set this property, Quarkus will fail, saying, "Hey, you have two container image extension, and you need to just select one."
Yeah. Okay.
Yeah. So after doing this, you will see in the generated in the target folder, you will see a new folder called Kubernetes. When you are adding the Quarkus OpenShift extension, you will also produce the Kubernetes artifacts. So these artifacts are ready to work with plain Kubernetes clusters. And these are the artifacts we are interested in because these are the one we will use in OpenShift, in our OpenShift instance. In this file, you will see all the resources we need for our deployment, the service, the deployment. The deployment will use the container image we have configured and the root we have exposed. If we install this single file, our deployment will work because our container image is in a container registry. But let's now configure the Quarkus Helm extension. First, let's add Helm, the Quarkus Helm extension. This extension is in Quarkiverso. So Quarkus Helm will use these two files as an input and will generate, without doing anything else, the Helm chart. Let's see how it looks like. And here is where the Quarkus Helm extension is doing some magic to, first thing, it will take this file and it will split this file into several resources by kind. So it will create a root.yaml file. We'll see this better. This is the folder that the Quarkus Helm is creating. Quarkus Helm will detect that there are two deployment files. These two deployment, the Kubernetes and the OpenShift, it will create the chart for each one. This is the basic chart.yaml file with the application metadata. You could find, you can configure this using the Quarkus Helm configuration. And as I say, Quarkus Helm will use the OpenShift.yaml file and will split the resources into these smaller files into deployment.yaml file.
This is just because that's the convention used for Helm charts, right?
Exactly. This is not reinvented well. This is how Helm recommend to create charts.
Yeah.
And the most important feature for Quarkus Helm is automatically, without providing any configuration, it will map some properties inside these templates to be able to override this configuration using the values.yaml file. And one of these pre-configured properties is the image. So as you see, the generated resources within the template is using this Helm expression, which means it will use the value within the values.yaml file, the app image, which is in app image. So when installing your chart, it will use this value as a container image. But you can overwrite it when installing your chart. So this is how Helm works. This automatically works for several pre-configured properties like the container image, health checks, ingress host, root path, this kind of properties. So far. So another important thing is we are going to push these resources, the Helm chart, into the Git repository. So we need to configure we need to move this folder into the upper level, for example, so we can commit this change because usually the target folder is ignored by Git. So let's configure Helm, say, hey, my output directory now is in the upper level in Helm. Now, if we build our application again, now this folder is not generated here, it's generated in the upper level. And you can set here, I use a relative location, but you can use an absolute location, any one you prefer. So I think for the basics, we are ready to start this application using and to start creating the application in Argo CD. Let's wait for the new is here with the two charts, one for Kubernetes, another one for OpenShift. So let's add let's commit the changes first, and let's push, and let's go to Argo CD. Let's go to. This is how it looks like Argo CD. So the first thing we need to do is to create the application. We provide a name. The project name is configured when setting up Argo CD. I'm going to use the default. You can configure Argo CD to manually synchronize your application or automatically. Let's use automatic because this is what's actually what we want to demonstrate. And then there are two options here. We can use a Helm repository or a Git repository. Let's use the Git repository. And the branch is main or head, doesn't matter. Now, this is how you will see that Argo CD is really well integrated with Helm, because Argo CD will automatically detect the charts are found in the Git repository. I'm going to select the OpenShift one, and where we want to deploy our application. Let's use the default one I prepared for the demo. And this is another feature that from the user interface, you can provide some parameters. So here I could select a new image or use a different values.yaml file. So let's create this application, and we see this is really fast because you don't have any dependencies. You from the Argo CD, you will see all the resources that are installed. Let's go to the root to call our hello endpoint.
Did you have to give it credentials to the cluster, or is the cluster also on the Argo CD demo server?
The cluster is I am using an OpenShift instance from my team, from the Snowdrop team. It's not for the public.
Got it.
Okay. And this is the hello from GCC reactive. So it worked now. Oh yeah.
Yay.
So let's overcomplicate this demo. Let's back to IntelliJ, and let's start creating an application using a database. Okay. For this demo, I'm going to use the.
Okay, just before you go on, so just want to highlight sure. Because you showed Lily the whole shebang, which is good. Like, this is all the stuff this enables. But I think it's important to highlight, so the Argo CD part is they said the icing on the cake, that you could also have had Helm. Like there's people who just like to use Helm raw, which they can. They've always been able to do it. They just have to write these files manually. Now we have that generator. And then what you showed on top of that was that if you use an Argo CD, you would this now have an easy way of just trying it out all the way through without, you don't barely have to know any Helm to do it. So because I managed to do it, so it's not that complicated. So that's amazing. This is awesome. So I just wanted to point out that you don't need to use all these steps, but it's just what this enables you to, from 0 to 100 in very short time. So that's very nice.
Sure.
Okay. All right. So go ahead.
Okay. So let's start by to add support of databases. I'm going to use Hibernate, the OREM. And I'm going to use the REST data with Panache extension that will automatically generate the resources using an entity. So let's start by adding it. I'm going to use a Postgres database. You could use any other at your choice. That's it. So let's start creating our first entity. A fruit. Let's Panache. Sorry, IntelliJ. Panache entity. If you go to the Panache entity, you will see the primary key ID column is already in there. And let's add a new column name. This is an entity. Okay, so good so far. And let's configure the REST data with Panache by adding the fruit resource. Because REST data with Panache, you can configure, you can automatically generate your resources from an entity or from a resource. Because I'm using an entity, let's use the Panache entity resource, the fruit, the type of your primary key, which is a long.
Yeah.
Okay. Just to have some initial data, let's add an import SQL file. Let's insert some data. Fruit, ID, name, some values, banana, and apple. Okay. If we start this in dev mode, just to confirm everything works fine, we will see that dev mode will set up a Postgres instance by you without doing or configuring anything else, because dev mode detected that you configure the Postgres driver. So magically for you, it will use this Docker, this Postgres image, and eventually we can invoke the fruit resource that is automatically generated thanks to this interface. Let's wait a minute for the.
Yes, for now, you're just using dev service, right? No Helm.
Yeah, no Helm, nothing. Just dev mode. Actually, we can see that the Postgres instance is here. Is already up and running. Let's try to check if our fruits are there. Yes. But unfortunately, we don't have dev mode when running an application in production. So
it was a missing feature, I'm sure. We should have done that.
So first of all, for the demo purpose, let's add these two properties just to use the import.sql file in production, and also to drop and create the schema every time we start our application. You shouldn't ever use these properties in production. Okay.
Yes.
What else? Yeah, the main challenge now is how you can configure the data source, which is a Postgres data source database, in production. For doing this, there are many approaches. I'm going to provide this configuration using system properties, these three properties. So right now, our application should be ready. As long as we provide these three properties, it can connect to any Postgres database, which is, of course, available at the moment we start our application. So let's increment the version, because this is the 2 version, including the database support, and is our fruit database. And how we can, let's build our application just to build the new container image and to push the new image into the registry. And then the question now is how we can bind these 3 properties when deploying this application using OpenShift. The question is, we can configure the OpenShift extension or the Kubernetes extension using providing the bars you want to provide. Let's use. The problem now is you don't know which is the actual value you want to use at build time. It failed. Well, yes, because I didn't configure the driver for test. So the main challenge now is at build time, when we are building or updating the Kubernetes artifacts, you don't know what value is here. So for now, let's just have some dummy data, user and pass. But the important point is that these mBars values will be mapped in the deployment resource. So we can see now, a second, in Kubernetes. We will see that our deployment resource is here. You will see, well, didn't take the latest property. Let's go by 11. But this is the important point. We can see that in their generated resources, we'll see these values. And as I mentioned before, the Quarkus Helm extension will automatically map some configuration like the container image. And another configuration that will automatically map is these mBar values. So in the chart, if we go to the chart again, we'll see that the template we have replaced these values with this Helm expression. So you can override these 3 properties when installing your chart. Is updated now. Okay. So the most important point here is a way you can configure your chart when installing it. This is the most important point. But do you have question about this? Shall I continue?
Sounds good.
Okay. So, but where is my Postgres instance? Helms allows you to set up dependencies when installing your chart. So you can configure Helm to say, hey, I have a dependency which is a Postgres dependency. My Postgres dependency is in the Vietnamese Helm repository. So in this repository, you can see a chart called PostgreSQL. I'm going to use this version. And also, I want to provide an alias, so I can configure this dependency using this alias. Now, we need to provide the values, the database name, the username, the password, And what I'm going to do now is coming from the Bitnami Postgres documentation. It's not up to the Quarkus Helm extension, but the important
Bitnami URL, is that to a Helm chart?
Yeah.
That you're pointing, yeah.
This is a Helm chart. Yeah. So if the way to provide the database name, you can configure, you can provide more values using this map, the key and the value. And for the username and the password, I'm going to copy and paste. This way, now, if we generate again our health chart, you will see that these three values will be part of the new generated YAML file. And meanwhile, this is building, I'm going to say something else. At the moment, this won't work because the Bitnami image needs full access to the cluster, and OpenShift doesn't allow this scenario. So this is coming from the Bitnami documentation. If you want to run this Helm chart in OpenShift, you also need to provide all this information. I don't want to scare you, but it's necessary. Okay.
Oh.
I'm sure, because I made many typos and mistakes, this is really challenging to provide all this information in this format. Let's see it first. The first three is already mapped, so it worked. But let's easy up this setup by providing our custom values.yaml file. So if you go to the source main and create a new folder, let's call it, or it should be called Helm, you can configure the input folder and create your custom value.yaml file. It's now much easier to provide this information in YAML format. So now you don't need anything like this. Even you don't need this as well, because I provide the new properties using this value.yaml file. Now Quarkus Helm will first check if the user provide their own values.yaml file, and will integrate this configuration to the generated value.yaml file. But there is something else missing, is a way to override this property, this property. So we need to, in the generated value, we need to provide a different value here according to the new dependency that we just created. And the way to do this, if we want to continue using our custom values.yaml file, is I don't want to use the one from the deployment resource. I want to use mine. This is the same database name here, and the port that the Postgres is listening. And now if we build again our chart, we should be ready to push these changes to the G repository. But as a summary, what we did is first to configure the dependency. So we now know we now know that a Postgres database will be installed as part of your application. The first thing we need to do is to configure this Helm dependency, and you will need to know more about how to do this in the source, in the documentation of the dependency. We also have seen how easy it is to configure things using Quarkus Helm extension. Let's commit all our changes. Let's push. And now our application here will eventually see that there are new commits in our Git repository, the timeout in Argo CD is 3 minutes, but if you are in a hurry, you can click on the sync button. But as you can see, this is quite fast. And now we will see that the database is starting. The application will wait for the database be up and running so it can properly start. So if you have more questions or something you want to clarify meanwhile the application is starting?
Yes, just so you're just showing the thing you dumped into the properties was just if you wanted to use a project file, you could do it this way. And the only reason why there's so many is just that's the nature of how to wire up services, right? There's like no way around the different the values, right?
Yeah. I mean, you need to configure your yeah.
Yeah. Okay.
Yeah. So the database is started, our application as well. So let's call to the fruit endpoint and check my fruits are already in OpenShift. So it worked. Now I want to say that Quarkus Helm extension can automatically push the generated chart indirectly to the Helm repository. And for doing this, you still don't need Helm command line. So for doing this, let's configure the repository type. There are up to 3 types of Helm repository: the Artifactory, Nexus, and Chart Museum, which is a kind of demo purpose Helm repository. So let's use this one, the one I installed in OpenShift. The URL, this is the URL of my repository. Is empty because I didn't push any chart so far. Now, because when using the Quarkus OpenShift, it will bring the Kubernetes deployment kind as well. We need to select only one deployment target. Let's use the OpenShift target because this is the one we have been playing so far. And let's enable the pushing to the Helm. So now when building my application again, you will let's disable the generation of the tool just to see quicker that we are pushing the chart to the Helm repository. Selecting target OpenShift. And the final feature I wanted to demonstrate is mainly about the Quarkus Helm, because as you have seen, the most powerful feature is already here. So if we click on it, we will see, hey, our chart is here. So the final bit I wanted to demonstrate is the most powerful feature is a way to bind the properties to the generated resources, to the generated Kubernetes resources. So I mentioned that Kubernetes Helm only supports a few of pre-configured properties: the container image, the ingress host, this kind of properties, the health checks. But what about if a user wants to configure other kind of property? So let's see how easy it is to map, for example, the image pool policy property. So before continue, just I wanted to mention that internally, Quarkus Helm extension is using YAML path framework, which is another framework we have developed as part of the Quarkus Helm. Is based on the JSON path, but the expression to use are much simpler to use and to understand, and also allow us to implement any features we have been missing in the JSON path. And of course, it supports directly YAML files. So let's map this property, the image pool policy, which is within in the first container. The way to do this, let's disable the pushing, is to say, hey, my value now is, you can provide any one you want to. This is just a name policy, and where is my property. I don't need to see above it. Let's use a wildcard expression and say is in a container. I don't know where. The name of my container is Ahmed. So in a container with name is Ahmed, and then the property is called schema pool policy. Oops. So when building again our application, you will see that a new property is going to be added into the generated values.yaml file, and this property is going to use a Helm expression to map this property using the values.yaml file. Not yet. It should be there now. It's here. And the Helm expression is using the property we configure.
Okay, hold up. Okay, in the property file, the application properties, can you go back there? I just make sure I understand this correctly. Can you make a bit? Yeah. So the expression, sure. I understand the expression that, hey, this is gonna go out and pick the value of image pool policy that matches this thing. Where is image policy paths referenced?
This is where you can configure the YAML path expressions. So we are saying here, as part of the generated values.yaml file configuration, I want to add a new property, and this new property will be mapped using this YAML path expression. So Quarkus Helm will try to find the path, the tree that will match this expression, which is in this case is a container with this name, and this is the property we want to map.
So what throws me off is it says paths with a how can you have multiple paths?
Exactly. This is another important point. This is a comma separated property.
And then if you have multiple values, it becomes a list or a string or
exactly. For example, let's try to map this another. I want to add a new property called label version, and in any place where there is allow labels here and here, I want to configure this value. And as you can see, this is a comma separated property. This is the comma.
Yeah.
Okay. So after running again, we'll see that now these two places will be mapped with the same property in the values.yaml file.
Yeah.
Eventually.
Yeah. So the paths is a hint. If you don't put that, you can put a direct value or.
This is another important point. Let's first see that the label version is now taking the value we had previously in the deployment.yaml file, and the Helm expression is now in these two locations, in here and in here. And another important, sorry, go ahead.
Right, yeah, no, I got it.
Okay. And another important point is you can override the value we had in the deployment at first place in the deployment.yaml file, and override this value to use something else. For example, I don't know, there is a new property called value, another. And in this case, always won't be part of the values.yaml file. Is going to be used another. Not yet. And that was all what I wanted to introduce. So time for question, I guess.
Yeah, that's really cool.
Okay. Well,
I
think you explained it pretty well. The last one with the paths and stuff is I know you explained to me before, and that's just I know what but it's very powerful that like this is the whole idea of us. We wanted to make something that can generate fairly, easily, but also open up for, hey, I want to do a few things and not having to fall back to the full hand editing of files. So it's really, really powerful if you get your head around it. And I think it's important to let people know that even though you can do all, like, none of this is a requirement, and none of it. So you can just, if you like, hey, I like kubectl and Helm and Argo CD 20 different commands, you can do that, or you can also just use the stuff we generate as a get started first.
Exactly.
Or have it updates again and again. Depends on your use case, what makes sense. Yeah.
The most important properties are automatically mapped, so you don't need to deal with that.
Yeah.
And this is a summary slide about what the Quarkus Helm is doing. Is has an input the generated artifacts by the Quarkus Kubernetes extension, and that's it. This to sum up, are all the features because Quarkus Helm, something I didn't have time to demonstrate, is also support full and complex Helm templates. Is a way to modify the resources, including adding functions or pipelines. And it also supports Helm profiles, just to provide different values to YAML file, for example, to use another host for development or this kind of stuff.
Yeah, very cool.
And that's all.
Awesome. Well, we had a quiet crowd today, but if they have quite, we'll give them a few minutes to stop. It works. Since which version of Quarkus does it work with? Quarkus 2.13 or 4? What version of Quarkus does it work with?
Let me check. I don't know. This is the Quarkiverse documentation. It works from Quarkus 2.
Perfect. Awesome. Okay. No, and the last thing is, I know that if you go into OpenShift, it has a Helm catalog. In there is a Quarkus one. That one is a static one. So this, if you want to have one that adapts to your application, then this is the approach to do it. So that's cool. Well, thank you, Jose. We don't have any other questions, so all is good. And we'll sign off.
Okay. Yeah. Thank you.